Okay, so today we are going to start our new topic in the topic polynomial. That is, in the previous class we discussed about the relation between the zeros and coefficients of a quadratic polynomial. Today we will discuss the relationship between the zeros and coefficient of a cubic polynomial. So our today's topic is relationship between zeros and zeros coefficients of a quadratic polynomial of a cubic polynomial. That is our today's topic. Now, how can we find the relation between the zeros and coefficients? First of all, let us write down the general expression of a cubic polynomial. Okay, so first of all, we write the general form. That is general form. Now, general form of the cubic polynomial can be written as p of x is equals to ax cube plus bx square plus cx plus d, and coefficient of x cube should not equals to 0. A is not equals to 0. That is the general form of a cubic polynomial. Now let the zeros of this cubic polynomial be alpha, beta and gamma. Okay, let the zeros let the zeros be alpha, beta and gamma. Okay, now again, since alpha, beta, gamma are its zeros, then x minus alpha, x minus beta and x minus gamma will be the factors of this cubic polynomial. Now how can we write this? Means it can be written as ax cube plus bx square plus cx plus d is equals to k times, k times, that is x minus alpha multiplied by x minus beta and finally multiplied by x minus gamma. Okay, now if we simplify this expression on the right hand side, it will comes out to be, that is k times, and this expression comes out to be, that is x cube minus x square in bracket alpha plus beta plus gamma, then plus x times, that is in bracket alpha beta plus beta gamma plus gamma alpha, and finally that is minus alpha beta and gamma, minus alpha beta and gamma. Okay, this is the expression after simplification. Okay, now what we will do, again we will compare both sides. Okay, now comparing the coefficients of x cube, x square, x and the constant term on the both side, we will get, what can we get? Okay, we will get sum of the zeros. Okay, sum of the zeros means alpha plus beta plus gamma, okay, comes out to be minus b upon a after simplification. Okay, so that is the sum of the zeros. Sum of the zeros alpha plus beta plus gamma can be written as minus b upon a. That is the first relation. Now if we equate the coefficient of um, x both sides, what we will get, that is product of the, that is the sum of the product of the zeros taken two at a time. Okay, so second expression we can get here, that is sum of the zeros, sum of the product of zeros taken two at a time, taken two zeros at a time. Okay, and how can we written it? It can be written like this, that is alpha into beta plus beta into gamma and finally gamma into alpha, and it will comes out to be c divided by a. That is the second relation what we obtained from. Then we come to the third expression. Then finally product of the zeros. Okay, third relation we can find here, that is product of the zeros, product of the zeros, that is alpha into beta into gamma. It is equals to minus d divided by small a, that is the product of the zeros, means value of alpha beta into gamma. Okay, so from here we will find the relation between the zeros and the coefficients. One is the sum of the zeros, next one is the sum of the product of the zeros taken two at a time, and finally that is product of the zeros is alpha beta and gamma. Okay, now here again we can write an important note. How can we write? Okay, if we know the sum of the zeros, we know the sum of the product of the zeros taken two at a time, and we know the product of the all three zeros, then we can write down the cubic polynomial like this. Okay, so here we can put an important note, that is if zeros of a cubic polynomial are alpha beta and gamma. Okay, zeros if zeros of a cubic polynomial if zeros of a cubic polynomial are alpha beta and gamma, are alpha beta and gamma, then the cubic polynomial is given by, then the cubic polynomial is given by, that is p of x is equals to, that is p of x is equals to k times, that is x cube minus x square, and sum of the zeros, that is alpha plus beta plus gamma, plus x times, that is sum of the product of the zeros taken two at a time, alpha beta plus beta gamma plus gamma alpha, and finally product of the zeros, that is alpha beta and gamma. That is the cubic polynomial whose zeros are alpha beta and gamma, where k is any constant, where k is any constant, where k is any constant. Okay, now let us solve some problem on base the relation between the zeros and coefficient of a cubic polynomial. Okay, so we solve the first problem, that is first question. Find the zeros of a polynomial. Find the zeros. Find the zeros of a polynomial. Find the zeros of a polynomial. P of x is equals to x cube minus 5x square minus 2x plus 24. If it is given that, if it is given that, if it is given that product of its two zeros, product of its two zeros is 12, product of its two zeros is, okay, then we have to find the all the zeros of the cubic polynomial. Now we come to the solution of this question. How can you solve this? Okay, first of all let us write down the polynomial, that is p of x, it is denoted by p of x, it is equals to, that is x cube minus 5x square minus 2x plus 24. Okay, from this equation we can write the value of a, that is coefficient of x cube, that is equals to 1, value of b, that is the coefficient of x square, that is minus 5, then the value of c, that is the coefficient of x, that is minus 2, and finally value of d, that is the constant term, that is equals to 24. Now we write down all the three relations between the all three zeros. Okay, so first of all let us use the product of the zeros, that is alpha beta into gamma. So here we can write it is alpha beta into gamma is equals to minus d upon a. So from here value of alpha beta into gamma comes out to be minus 24, value of d is equals to 24, and value of a is equals to 1. Now since in the question we are given that product of any two zeros is equals to 12, means alpha into beta is equals to 12. If we substitute this value of alpha into beta in the above equation, we will get the value of gamma as, means that is 12 into gamma is equals to minus 24. So value of gamma comes out to be minus 2. That is the first zero of our cubic polynomial. Okay, now let us use the another other relations between the coefficients and zeros, that is sum of the zeros, means alpha plus beta plus gamma, alpha plus beta plus gamma, that is equals to minus b upon a. Okay, if you substitute the values, then alpha plus beta plus gamma comes out to be 5. Value of gamma is equals to minus 2. So alpha plus beta minus 2 is equals to 5. So from here we get an equation alpha plus beta is equals to 7. Okay, that is our first equation. Now since we are given alpha into beta is equals to 12, so other relation is that is alpha into beta that is equals to 12. So from here we can find value of beta in terms of alpha. Beta can be written as 12 divided by alpha. Now if we substitute this value of beta in equation 1, what we will get, that is alpha plus 12 upon alpha is equals to 7. If we simplify this equation, okay, if we simplify this equation, it will convert it into a quadratic equation, that is alpha square minus 7 alpha plus 12 is equals to 0. Now we can factorize this quadratic equation by using middle term splitting. Okay, so the factors of this equation are 3 and 4. So it can be written as alpha minus 3 into alpha minus 4 is equals to 0. Means value of alpha can be equals to 3 or it can be equals to 4. Now we take the two cases. When the value of alpha is equals to 3, then value of beta comes out to be, that is 4. Okay, when the value of alpha is equals to 4, then value of beta comes out to be 3. Okay, so here we can write zeros are, means all zeros are, okay, zeros are, that is 3, 4 and minus 2. That is our final answer. Okay, so by this way we have used the relation between the zeros and coefficients of a cubic polynomial. Okay, now let us solve few more problems based on this topic. We come to the next problem. Now that is second question. Okay, we are given if the zeros of a polynomial, if the zeros of a polynomial p of x is equals to x cube minus 12x square plus 39x plus k, okay, are in AP. Okay, then find the value of k. Then our question is, then find the value of k. Okay, now come to the solution of this question. How can you solve this question? Okay, first of all write down the polynomial. It is p of x is equals to x cube minus 12x square plus 39x plus k. Now let us again, if we compare this equation with the original or general form of the cubic polynomial, we can get the values of a, b, c and d like this. A is coefficient of x cube, that is equals to 1, coefficient of x square, that is minus 2, then c coefficient of x, that is equals to 39, and finally coefficient of the constant term, that is equals to k. So we were discussing the coefficients of x cube is equals to 1, coefficient of x square is equals to minus 12, okay, value of c is equals to 39 and value of d is equals to k. Now since we are given that the zeros of this cubic polynomial are in AP, means they are forming an AP, so in arithmetic progression we can take the zeros like this. Let the zeros are that is alpha minus g, alpha and alpha plus d. Okay, we have assumed the zeros in AP like this, alpha minus g, alpha and alpha plus d, where d is the common difference between the two consecutive terms. Now sum of zeros, okay, is equals to minus b divided by a. So from here if we add all the zeros, that is alpha minus d plus alpha plus d gets cancelled out and it is equals to 12, means 3 alpha is equals to 12 and value of alpha comes out to be 4. Now we use the next relation, that is sum of the product of the zeros taken two at a time, that is alpha into beta plus beta into gamma plus gamma into alpha, that is equals to 39. Okay, now we substitute all these values, that is alpha minus d into alpha plus then alpha into alpha plus d and finally alpha plus d into alpha minus d, that is equals to 39. Okay, now if you simplify this expression, we will open the brackets, then alpha square minus alpha d plus alpha square plus alpha into d, finally that is a plus b into a minus b, matlab alpha square minus d square comes out to be 39. Okay, so here alpha into d gets cancelled out, value of alpha is equals to 4. If you substitute the value of alpha, means 3 alpha square minus d square is equals to 39. If you substitute the value of alpha is equals to 4, means this expression will be converted into 3 into 4 whole square minus d square is equals to 39. So value of d square comes out to be 9. Okay, so d is equals to plus minus 3. Now we come to our final relation, that is product of the zeros, that is alpha into beta into gamma is equals to minus d upon a. Alpha into beta, sorry, that is product of the zeros, that is alpha beta into gamma is equals to minus d divided by a. Now if we multiplied all the zeros, means that is alpha minus d, okay, multiply by alpha, then alpha plus d is equals to minus k. If we substitute the values of alpha and d in this equation, it will convert it into a alpha into alpha square minus d square is equals to minus k. Value of alpha is equals to 4, that is, and value of alpha is equals to 4 square, d square is 9 is equals to minus k. If you simplify this equation, you will get the value of k is equals to minus 28. Okay, so that is our final answer. We have to find the value of k in this equation. So by this way, we have used the relation between the zeros and coefficients of a cubic polynomial. Okay, that's for today. Thank you.